So today we're going to be looking at Chapter 8, Section 5. This section is titled Inequalities. We're going to be practicing with less than and greater than again today, but you'll notice we have two new symbols to work with. So let's take a look at the chart at the top of your page, 618, and go through the symbols we know and then the symbols that are new. So looking at the chart, in the first column, we have our typical less than symbol. Less than can also be said as fewer than. And our example here, 3 is less than 5, or 3 is fewer than 5. In the second column, we have greater than. It can also be said with the words more than. So our example, 8 is more than 4. In the third column, we have what's called less than or equal to. So this symbol represents two things. It could mean a number is less than something else, or it could mean a number is equal to something else. Here we have 7 is less than or equal to 10. Well, in our minds, we know that 7 is actually less than 10. 7 is not equal to 10. But this sign works because it says 7 is less than or equal to 10. And we know that 7 is less than 10. Then we have a greater than symbol with an equal to bar as well. This one says that a number is greater than or equal to something else. So as long as one of them is true, then this whole inequality works. Let's take a look at what that's going to look like as we practice with numbers. So I'm going to scroll down here to example 1. You'll see that in example 1, we have the numbers 6, 7, and 8. And the question asks which one of those is a solution, which is an answer, to the inequality f plus 2 is less than 9. If you want to circle and underline with me as we go through this, I think it'll help you understand the process better. So we're going to be replacing the f here with a 6 and working it out. Then we replace the f with a 7, and then we replace the f with an 8 to see which one can be a solution for the variable f. So here we're looking at f plus 2 is less than 9. We try replacing the f with a 6 and ask ourselves whether or not it works. So in this case, we get 8. And is 8 less than 9? It is. So this one checks out fine. Next, we replace the f with a 7. And we get 7 plus 2 is 9. Is 9 less than 9? No. So f cannot be 7. And finally, we have here an 8. So we replace the f with an 8. And 8 plus 2 is 10. Is 10 less than 9? No. So the only thing that can replace f in this particular given set of numbers is a 6. So we would say that 6 is the only value that could make this statement true. So if you wanted to write that on the side, in this case, f equals 6. So we've got a got it problem here at the bottom to try on your own. It says, of the numbers 8, 9, or 10, which one is a solution of this inequality? N minus 3 is greater than 6. So I want you to take the 8, the 9, and the 10 and replace the n with each of those numbers to see which one will get an answer that's greater than 6. You may pause the video here to take a moment and work that out, and we'll come back together to check the answer. Okay, so let's see if we got this one right. Of the numbers 8, 9, and 10, which one is a solution of the inequality n minus 3 is greater than 6? Well, if I plug in an 8, I get 5 is greater than 6. That doesn't work. If I plug in a 9, I get 6 is greater than 6, and 6 is not greater than 6, so that doesn't work. It looks like 10 minus 3 is 7, and 7 is greater than 6. Therefore, n could equal a 10. All right, let's move on to the next page. I see here at the top of 619, how do we write solutions for inequalities? So basically, let me explain this differently for just a second. If I have the inequality x is greater than 4, notice I'm circling that up here in the example for us. So if x is greater than 4, that means x could equal 5, x could equal 6, 7, 8, 9, 10, all the way to a bajillion. So x could equal anything that's above 4. The purpose of explaining this is to show you that in this example with inequalities, you can have multiple solutions for x. X could be all kinds of things. It's not just one specific number. That'll make more sense as we do a couple examples on this page. So look here at example 2. We have x plus 3 is greater than 9. And they want us to determine whether or not 4 is a solution. So I want to try this out right here to see if it works. So if we replace the x with a 4, we get 4 plus 3, and that's 7. Is 7 greater than 9? No. So that means 4 cannot be x. So it has to be something different. So we just answer this with a no. Let's take a moment and do the stop and reflect on the right over here. I think it's important that we notice y or x or whatever the variable is can be multiple things. In this situation, we need 6 plus something to be less than 12. Or I can say we need 12 to be greater than whatever's here. So here's a sample answer for you. I could make the y a 4 because 6 plus 4 is 10 and 12 is greater than 10. We could also make the y a 5 because 12 is greater than 11. Y could be 1, y could be 2, y could be anything as long as this side here is less than 12. So that shows us a similar example to number 2, but with it written the opposite way, the variables on the right. Okay, let's continue on and look at example 3. I hope it's making sense so far. We're just plugging in a number for the variable and checking to see if our inequality is true or not. So here in number 3, I have y equals 6. So I have 18 minus 6. Is 18 minus 6 going to be greater than or equal to 12? And I'm saying it that way because I'm thinking backwards here. But really, we can read it from left to right. Is 12 less than or equal to 12? Well, 12 is not, whoops, there we go. 12 is not less than 12, but 12 is equal to 12, so this one works. Okay, let's see about the last few here. Okay, so number 4, we'll breeze through this one pretty quickly. X equal to 8, is that going to work for X? So when I plug in the X, I want you to put an 8 in this block. And we're asking ourselves, is 17 greater than or equal to 19? Now, if you forget what the symbol is, you can always go back to page 618 and refer to the chart. So 17 greater than or equal to 19. It is not, and that's why they have the bar drawn through the inequality like that. It's showing it's not greater than or equal to 19. So we would say here, since 17 is not greater than or equal to 19, 8 is not a solution. So 8 does not work there. Go ahead and pause the video. I want you to try B, C, D, and E on your own. All right, now that we're back together, let's check the answers for B, C, D, and E. Take a look on the right here and see if that's what you've gotten. If not, you may want to conference with classmates and see what the mistakes are. All right, we're almost finished. We have one more example to go through, and this is on the top of page 620. This is a real-world example referring to balloon sales at a gift shop. So let's take a look and see what the situation is. Louisa works at a gift shop. She receives a bonus if she makes more than 20 balloon bouquets every month. Which months did Louisa receive a bonus? Use the inequality B is greater than 20, where B represents the number of balloon bouquets made each month. So over here, we're trying to determine when Louisa received a bonus. So she has to make more than 20 bouquets. So did she earn a bonus here? Is this more than 20? Yes. Did she receive a bonus here? No. September? No. But October? Yes. So what we were doing is basically plugging the 25 and the 32 in for B and seeing if it worked or not. So let's confirm our answer with theirs. It says Louisa earned a bonus in July and October. Well, that's also what we got. So great job with that. We're going to do 1 through 5 of the guided practice together. This is another good time to pause the video and we'll come back and check our answers. Work with the people around you at your table if you need any help with these. And I just want to point out here on number 4, remember an 8 push next to an N where they're smushed together means multiply. So you'll want to do 8 times 3 for this one. Okay, go ahead and pause the video. Now that we're back together, the answers for 1, 2, 3, 4, and 5 are here. 1 is 7, 2 is 16, 3 is no, 4 is yes, and 5 is on Friday and Saturday. If there's any questions, go ahead and take a moment to discuss whatever issues may have arisen during the working out these problems. The last thing we're going to do together is work out page 621. We're going to do the odd numbers. So I want you to circle number 1. Get my pen here. Number 1, number 3, number 5, and also number 7. So go ahead and take a look at the directions for each set. You may use the examples we just went through in your book to help you. Um, on number 1, you're going to write which number works. Number 3, you're going to write yes or no to determine whether or not the number they give you works. Number 5 and 7, I want you to read through the situation and refer to the table to help you come up with your answer. We'll go ahead and pause the video and display the answers when we come back. Okay, the answers for 1 is 5, 3 is yes, number 5 is only the stand up or suspended type of roller coaster, and number 7 is just January and February. That's the end of our video. You're going to receive some work to do now that we'll check together on Wednesday. Have a great rest of the day. Work hard and help each other if you have questions.